Hi, I'm Brian. Today we're going to be going over an SAT math question involving equivalent expressions, more specifically with exponential functions and quadratics. So in this question here, we're given a question that says, which of the following is an equivalent form of the function f above in which the minimum value of f appears as a constant or coefficient? The key here is the minimum value. The minimum value of a quadratic shows up as the y value of its vertex. Remember, the quadratics take the form of parabolas, something like that, and the vertex shows up here at the bottom. That will always be the minimum value of a parabola with a positive leading coefficient, which is what this has. So in order to find that, probably the easiest way is to recognize that the x-intercepts of this function, the values that make this y value come out to 0, would be positive 2 and positive 6. So if you imagine a coordinate plane, we would have something like this. Here's one intercept, here's the other intercept. We know that the vertex has to show up in the middle there. So the vertex has to show up at positive 4 as the x value. Another way to think of that is take your 2 and your 6, add them up, divide by 2, and we get that positive 4. Now, we're looking for the y value of the vertex. So that 4 is helpful, but it's not our final answer. We want to plug in that 4 and see what we get here when we actually do the multiplication. 4 minus 2 is 2, 4 minus 6 is negative 2. We end up getting a negative 4 as the y value of the vertex. So really all we're doing here is just looking for the value negative 4 to show up either as a constant or a coefficient in one of the answers. Given that negative 4 shows up actually in 2 places here, makes this the only answer. There are a couple other ways to do this question involving turning this into standard form by multiplying or completing the square, but I think this is the best way to do it and the easiest concept to grasp here.